Hello, this is our CSC1101 concurrent warehouse simulation. Students 223-71553 and 225-06739. In this presentation, we will walk through the classes that we've implemented and show a system demo. Trolley pool manages a fixed number of trolleys using a fare semaphore. Acquire blocks when no trolleys are free, and the fare mode gives FIFA ordering so no thread is starved. Release throws an exception if the trolley still has boxes on it. The stalker acquires a trolley, takes up to 10 boxes from staging, then visits sections in priority order. Sections with waiting pickers come first, then empty sections, then sections with the most space. This minimizes picker wait time. After stalking, the stalker returns to staging, releases the trolley in a finally block, and takes a break every 2 to 300 ticks. Each picker sleeps for a random interval to hit roughly 100 picks per day. Combined, it acquires a trolley, randomly picks a section, locked in even if empty, logs pick underscore start, then calls pick box, which blocks until stock is available. It logs pick underscore done with weighted underscore ticks and releases the trolley in a finally block. Here are trolley weights. Picker P4 weighted 433 ticks for a trolley with 7 threads and 3 trolleys. Contention is expected, and a fair semaphore prevents starvation. Priority order events show stalkers visiting sections with waiting pickers first, and pick underscore done events show pickers that waited on empty sections until a stalker delivered stock.
This is the delivery thread class. It runs in a continuous loop. Each tick it rolls um, a random double. So if it's below 0.01, then a delivery fires. And then 10 boxes are randomly distributed across the 5 sections and dumped into the staging area. Then we have the staging area. So the staging area uses a reentrant lock, and it also has a not empty condition. When add boxes is called by the delivery thread, it signals the waiting stalkers, and if a stalker calls the take boxes function and finds nothing, it blocks on not empty or wait and releasing the lock while it waits, so delivery can still add boxes. And this is the section class. So each section has a reentrant lock and 2 conditions. So not full, stalkers wait on when the section is at capacity, and not empty, where the pickers wait on when it's empty. So in the stock function, the stalker holds the lock and places boxes one at a time. After each box, it signals not empty. So if a picker is waiting, it can wake up as soon as the first box lands. And if the section hits capacity before all boxes are placed, then the stalker exits the loop and returns a count of what is actually stocked. In pick box, the picker increments waiting pickers, and before entering the wait loop, this is what the stalker reads before its priority ordering. After picking, it signals not full, so any blocked stalker knows space is opened up. And then the weighted value subtracts the 1 tick pick time, so it only measures actual time, not work time. These are the test scenarios we did to test the concurrency behaviors. So in the first test, it starts at 0 boxes and then launches a picker immediately. So you can see pick start. The section is chosen and logged in, but there's no pick done yet. And then 400 milliseconds later, the stalker starts and stalks the section, and the picker unblocks. So the pick done line, this shows the weighted ticks, and it's greater than 0. So that's the time the picker spent blocked on not empty away inside the section. And then in the second scenario, the electronics are pre-filled to 8 of 10, and the stalker tries to place 5 boxes, only 2 fit. So you can see stock end here. So um, has a non-zero remaining load, so it equals 3 here, and the stalker clears the trolley on return, and release trolley only fires when the remaining load is 0. Then the last scenario, um, so this is the full system test. So there's 2 stalkers, 5 pickers, and 3 trolleys, and this basically confirms that there is no deadlock, and every stock begin has a matching stock end, and all assertions pass.